Hey students, in this lesson we're going to go over Boolean logic. Earlier in this section you learned that Booleans can only be true or false. However, what you may not know is that Boolean logic and Boolean algebra form the basis for modern electronics and computing. Zeros and ones are often used to present off and on as well as false and true in computing. In the last section, I mentioned that computers only understand ones and zeros, and that's because the electrical circuits and components are usually only on or off. A computer is basically a giant electrical circuit whose individual components are rapidly flipping on and off. Boolean algebra and Boolean logic allows us to model these complex electronic circuits as if they were mathematical equations. It's super cool stuff. But anyways, I digress. Let's get back to some of the practical knowledge. In Boolean algebra, you have three operators. You have the OR, you have the AND then you have NOT. These operators are sometimes represented by a plus sign, a multiplication sign, and then a bar over the element. Some other terms and symbols that you may hear which are less important, OR is also referred to as an injunction and is represented by this kind of V-shaped symbol, and is also a conjunction and is also represented by this kind of hat-like symbol, and then NOT is also referred to as an inversion. Now let's take a look at some of the behaviors and properties of Boolean algebra. All of these have names, but it's not important for you to know the names, you need to know the behavior as a programmer. I'm going to have two columns here for the AND and OR, which are going to be the main operators that you'll use in most cases. So let's say I have some variable A OR 0 is just A. When I'm ORing two values together, only one of these has to be true for the result to be true. And so when you OR with false, the result is just going to be the same as whatever the original value was. False or false is still false. True or false is true. Now, in contrast, whenever you AND anything with false, the result will always be false. Because when you AND multiple items, all of them have to be true for the result to be true. It's just like anything multiplied with 0 is still 0, which is why some people use the multiplication symbol to indicate an AND. Now, building on this knowledge, let's move forward. Anything ORed with true will always be true, because again, it only matters that one of these items is true. Anything ANDed with true is unaffected because the result just depends on what A is. And now we just come to some weirder properties. A or A is just A. A and A is also just A. Remember, in Boolean algebra, any value can only ever be true or false. And so, if you have false or false, that's going to be false. If you have true or true, that's going to be true. If you have false and false, that's also false. If you have true and true, that's also true. Moving forward, A or not A is always true. A and not A is always false. If I had to compare this to something, it's like saying you're either asleep or you're awake. Assuming the person is alive, then one of those statements has to be true. Therefore, saying that you're either asleep or you're awake is always going to be true. On the other hand, you can't be asleep and awake at the same time, and so that's always going to be false. I'm going to add some notes here on the side in case it wasn't obvious, but the inversion of 0 is 1, and then the inversion of 1 is 0. I'm also going to add here that 0 is often used to represent false, and 1 is often used to represent true. Now, continuing forward, Boolean algebra shares a lot of things in common with regular algebra as well. For example, when I OR two values together, it doesn't matter what order I do it in, the result is the same, and the same thing will happen if I AND two values together as well. The order doesn't matter. Likewise, if I group and operate on these things in different orders with parentheses, again, the result will still be the same whether you're ORing or ANDing them together. But now you must be wondering, what happens if you combine OR and AND operations together into one equation? Well, Boolean algebra also has an order of operations. Let's say I'm looking at A or B and C. I would first evaluate B and C. Let's say the result is D, and so the final thing I evaluate is A or D. And so the Boolean algebra order of operations goes like this. First, you have to invert any elements, then you have to AND items together, and then finally you evaluate the ORs. Let's look at another example that's a little more interesting. Let's say I have A or B and C again, but this time B and C, the entire thing, is inverted. Now, how do we solve this? Because we need to get rid of the inversions first, right? We cannot, unfortunately, just invert each of the individual items because that fundamentally changes the result. So, in Boolean algebra, there's this thing called De Morgan's theorem, which states that the inversion of two items ANDed together is the same as finding the OR of both items inverted individually. And De Morgan's theorem actually works both ways. Similarly, if you have the inversion of both items ORed, then that's the same thing as finding the AND of both items inverted individually. Now, why does this work? Let's take a look at our example of B and C again. We know that when we AND two items together, both items have to be true in order for the result to be true. But when we invert the whole expression, it changes the behavior. Now, if both values are true, then we get an outcome of false. Whereas if either one of the elements is false, then we get an outcome of true. And so, you can simplify this down to just inverting each element individually and then finding the OR of that. If this didn't make sense to you, that's okay. I'm just going over it with you once so that it's on your radar. De Morgan's will be useful in the far-off future when you're working with really complicated scenarios. For now, you just need to understand the basics of Boolean algebra and Boolean logic. And so De Morgan's is extra learning. And so now you must be wondering, what does any of this have to do with programming and coding? Well, we've learned about using conditions inside our code, right? Thus far, we've been doing really simple scenarios, really simple conditions, etc. Hey, is 5 greater than 3? Whatever. But more often than not, when you're writing real programs, you will have to consider multiple conditions at the same time. For example, let's say I'm writing an if statement, if true or false and true. There's a quiz for you. Will this run? Well, let's find out. First, we evaluate the ands, right? False and true results in false. Then we evaluate true or false, which is just true. So yes, this conditional statement would have run. Now, obviously, you wouldn't just hard-code Booleans inside the condition itself. So as an example, maybe you're evaluating different situations in your code. Maybe it's something as simple as what we've been doing, is 5 greater than 3. Or more likely than not, you're working with a user program and you're going to say, hey, does the user ID match a certain number and is the user an admin? If all of that results in true, then yeah, let them access the database. Things like that. Anyways, that's the theory. Let's try to apply it using the Python REPL. Inside the Python REPL, I'm going to set A equal to true and B equal to false. I'm going to print out the variables just for confirmation, but if I do A or B, you can see that the result is true. And then if I do A and B, the result is false. Now let's try using the numbers that we did before. Do 3 greater than 5. You should get false. Now if I do A, which is true, right? A or 3 greater than 5, A or false, that should result in true. Let's create a variable called num and set that equal to 5. Now if I do if B, which is false, right? If false or num greater than 5, print hello, hit enter a couple times, and then nothing happens, right? And that's because B is false, so you get false. Num is 5. Is 5 greater than 5? No, that's also false. False or false is false, and so the print statement didn't run. Just try chaining together and experimenting with various different conditions and then seeing what the results are, and you should see that the rules that Python follows are very consistent with what I just told you in this video. And so, to cap off this lesson, I'm going to give you a fun Boolean equation that you need to solve, figure out if it's true or false. And then in the next video, we're going to go over your final programming challenge of this section.